Acclaimed psychic medium John Edward! Good to have you. You'll be with us all morning. Fantastic. Now, it looks like the rioting in England has finally calmed down. I don't want to speak too soon because I could be wrong, but after 4 days and 4 nights and not without loss of life, it does seem to have settled. John Edward had a premonition about this.
Yeah, it was really strange. I was there for 19 days. I was touring all through the UK, and before I went there, I had my daughter with me who was 4. And before I went, my wife and I had a conversation, and she wasn't able to come with my son. And long story short, I had a weird vibe about going there, and I wasn't sure if it was going to be like a terrorist attack or if it was going to be civil unrest. And my wife was like, well, maybe it's not a good idea we take our 4-year-old daughter and you go. And I said, no, I said, we're going to be fine. Everything's going to be good. And it was like moments after we left there that this took place. I didn't know exactly what it was going to be. But I think somebody recently asked me what word scares me. And one of the words that scares me is the word ignorance. And the other word that I don't like is entitlement. And when you see stuff like that people would feel so entitled for whatever reason that they would be, it's okay to do that and exhibit bad behavior. It's scary.
Welcome to the Skeptic Zone, the podcast from Australia for science and reason.
Welcome to the Skeptic Zone, episode number 147. Richard Saunders speaking to you from Sydney, Australia, with a dog barking outside somewhere, which I can't do anything about. Be quiet! Rover. On this week's show, well, we kicked off with, John Edward. John Edward doesn't like the word entitlement, eh? People shouldn't be entitled to do naughty things. Really, John Edward? And what was the other word that scares you, John Edward? Ignorance. Thank you, John Edward, for your incredible hindsights about the riots in London. Well, let's just leave John Edward for the moment. But we do have some good things on the show. We have Dr. Rachie. Dr. Rachie Reports talking this week to Dr. Ginger Campbell all about brain science. Synapses, neurons, false memories, all that sort of stuff. You know, Dr. Ginger Campbell was our very first live guest on the Skeptic Zone when we did our very first episode from Dragon Con in Atlanta, Georgia in 2008. And so sad that we won't be visiting Dragon Con this year. This is the first time in 3 years that the Skeptic Zone haven't been to Dragon Con. Unfortunately, it's just a very, very, very long way to go. And, maybe next year. Maybe next year. So all those people going to DragonCon have a hell of a time on our behalf. Following Dr. Rachie Reports, we have a report I did with Karen Player from the Australian Museum. Now, Karen's involved with Museum in a Box, a fantastic outreach program from the Australian Museum. And she's the newest member of the New South Wales Australian Skeptics. Now, I've got a little note here from our good friend Lucas Randall, a great supporter of the Skeptic Zone. He's telling me that the Skeptic Camp was such a success here in Sydney that our friends in Melbourne are going to do the same sort of thing. They hope to have it happening in October, later in October this year. And they need your help, support, and general interest. I can really recommend Skeptic Camp. It was a fantastic day here in Sydney. I can't wait to go to the next one. So, if you're in Melbourne, if you're in Victoria, check out the website of Lucas. Run to blog.codenix.org, blog.codenix.org for more information about Skeptic Camp in Melbourne. And if you're in Melbourne later on in October, don't miss out on this fantastic event. Now, thanks to all the people who wrote in when I tossed the dice at the end of the last episode of the Skeptic Zone. So many people, more than I thought, actually said they predicted or they guessed or whatever you want to say, the numbers that came up when I tossed the 20-sided dice, the D20. And I have it here again, my lovely D20. What I'm going to do, I'm going to toss it 4 times in this episode. Once at the beginning, And then after the first interview, after the second segment, towards the end, you'll hear them. So you have 4 chances of guessing, predicting, using your psychic power to come up with the same number as the dice. Now, if you do it first off, that's a 120 shot. Well done. Now, if you get the first number correct and the second number a bit later in the show, that's a 1 in 400 shot. Not bad. If you get the first and the second and the third numbers correct, then that's a 1 in 8,000 shot. And if you get all 4 numbers correct, then you've beaten odds of 160,000 to 1. So get those neurons and synapses working right now. We're going to do the first toss. I'll give you a second. Oh, psychic predicting power. Here we go. Are you thinking of your number? From 1 to 20. Could be 1, can be 2, all the way up to 20. Here we go. Tossing now. The first number on today's show is 17. So, all those people who predicted 17, well done. All those people who didn't, don't worry, you'll get another chance soon. Well, I'll put that aside for the moment. I'm going to run downstairs. Here we go. I'm going to run downstairs. I'm going to make myself a paratha. Very easy to make, straight from the freezer, fry it up in the frying pan. Crunchy and lovely. Paratha, buy some today. And let you enjoy the Skeptic Zone.
Now it's time for Dr. Rachie Reports with Dr. Rachel Dunlop.
And I'm here today at TAM9 talking to Dr. Ginger Campbell. Hi Ginger, thanks for talking to us
Hi
today.
Rachel, it's good to see you again.
We finally got to have a chat.
Yeah.
Because last year we were meant to talk, and then I was so jet lagged and I was just in a bit of a daze at one point, so I just kind of went to bed, I think. So we missed actually catching up last year, didn't we?
Yes.
Yeah. So this is not your first TAM, obviously.
Just my second.
Oh, is it your second? Okay, it's my second as well, actually. And last year we did the workshops for science-based medicine, which we're not doing this year, but we're doing a panel on the placebo effect on Saturday, which is really interesting. The research I've been doing for that has been really fascinating. I want to talk to you about neuroscience today.
Okay.
Now, you have a podcast, the Brain Science Podcast, which you've been doing for quite some time. One of your recent interests, although you're not a neuroscientist, are you? You're a physician.
Yes.
What's your specialty?
Well, I trained as a family physician, but I've spent most of my career working as an emergency physician in rural, little small hospitals where a lot of what you do is primary care. So
yeah.
I do everything. I like the variety.
You like the variety?
I like the fact that every day is different.
Yeah. Recently you've become a bit interested in neuroscience, and you did a talk at London Skeptics in the Pub, which was broadcast as part of one of your podcasts recently, your Books and Science podcast.
Books and Ideas. Books and Ideas
podcast, sorry. Up front, can you give me a layman's sort of description of what is neuroscience?
Well, if I'd known you were going to use my last talk, I know I used a definition in there, and I've forgotten what it was. But basically, it's the study of how the brain and the nervous system work, and it can include anything from the molecular level all the way up to the level of the whole brain. I think Wikipedia's got maybe 15 different sub-branches of neuroscience listed. The definition depends on, in the field, people that are in neuroscience don't consider psychology part of neuroscience. But I think from the outside point of view, psychology even could be considered a related field.
Because the sort of, you in the talk that you gave at Skeptics in the Pub, you talked about C. elegans, which is actually a worm, isn't it?
Yes.
It's a very simple organism, and it's been used to study neuroscience. And that's because it's only got, 8 neurons, hasn't it?
Well, it has, I think, 302 neurons in total. The thing that makes C. elegans special is, first of all, it was the first organism to have its entire genome sequenced. And it's the only organism that we have the entire wiring diagram, so to speak, of every neuron. In C. elegans, every neuron is the same, unlike our brains. And they know what every neuron in the brain of C. elegans, doesn't have a brain, but they know what every neuron in C. elegans is connected to, which other neurons it's connected to. Where the 8 neurons thing comes in is that there's exactly 8
dopaminergic neurons.
Yes.
That's right, yeah.
But yeah, so they know the entire wiring diagram. So they know the level of detail that they know about C. elegans is beyond any other creature at this point in history. So it makes it a great thing for studying.
So in terms of evolution of neurons and the brain, it's a really good example of how the brain could have evolved, isn't it? Because it's got an example of synapses. So can you explain what a synapse is?
Can I back up on that question, though, for just a minute? Even back before C. elegans, we've got the evolution of what we now call neurotransmitters. Mm-hmm. The chemical messengers already exist even before the first neuron arrives. So that's important.
Yeah.
There's a guy named Seth Grant in the UK that's studying the evolution of the synapse and how the receptors and what becomes the neurotransmitters already exist even in yeast.
In yeast, really?
Yeah, which is way before even the first multicellular organisms. So the beginnings of the nervous system go almost, I'd say, to the back to the first single-cell organisms. Once they started moving around and they had to be able to go to good stuff and away from bad stuff, that's the beginning of the nervous system. So then the synapse is actually a very high level of complexity compared to all those organisms that existed for millions of years before there were multicellular organisms.
Yeah, well, I mean, you mentioned that the neurotransmitters evolved before neurons evolved, so that suggests that evolution started with the proteins that are the neurotransmitters.
Right.
And those are the sort of chemical messengers, aren't they?
Right.
And so the synapse is sort of the connection between neurons, isn't
right.
it?
The synapse is the place at which one cell, I think the easiest way to think of it is the place at which one cell sends out some chemical messengers and the other cell receives them. And once you get to where that's a specialized connection, where they're sitting there close to each other so that one knows that its message is going to that specific next cell, which in the case of the nervous system is a neuron, then you've got a synapse. And again, that happens fairly early on, as soon as you see the beginning of neurons. And I honestly don't know when the first cell that would be called a neuron arose. I don't know the answer to that. But it's a long time ago is the important thing to realize. And that most of what's going on in the nervous system, well, a lot of what's going on in the nervous system was happening even before we had a nervous system.
And so you talked about these proteins that are called neurotransmitters, Ginger. There are different types of neurotransmitters, aren't they, that talk to different types of neurons now in our brain, in our evolved brain, and that results in different things happening, right?
Well, the key is not so much the transmitter as it is the receptor. That's why when you hear about something like dopamine doing different things in your body and you wonder, well, how can it be, in my reward circuits and be in this other circuit like that I need for my movement? Say Parkinson's disease is a problem of the dopaminergic system, but that part of it's not a reward, it's movement oriented. So it's what you might say, what key what lock it goes into when it gets to the other end. So various neurotransmitters can have wide-ranging effects based on what receptor they connect with. This is important clinically because if you try to make a drug that's going to increase a transmitter, side effects arise because it's not just going to the place that you're thinking about, it's going to maybe places you hadn't thought about.
And so just to go back to C. elegans for a second then, we just touched on the fact that it's got 8 dopaminergic neurons. Now those are involved in Parkinson's disease in the sense that they're lost in Parkinson's disease, which is why people get this shaking and their inability to control movement. And that organism is being used to study possibly drugs to help with Parkinson's disease, isn't it?
Yeah, the other thing I forgot to say about C. elegans that makes it great for studying is the fact that it's transparent.
That's right, yeah.
And they can actually see the neurons. And then they have this green fluorescent protein thing that the guy got the Nobel Prize for, so they can actually sort of label the neurons, and you can see them sort of bright green, shiny little neurons. You know exactly which ones are the ones you want to study are lit up, so they can do that. And then in the talk that I gave in London, I showed a picture of the C. elegans, and Guy Caldwell, who gave me some slides to use, he also gave me a video showing they've actually even figured out C. elegans can have seizures. Multiple kinds of seizures. This does not involve dopamine neurons, but it's another example of how C. elegans can be used. And the fact that I have to admit, though, a seizure in C. elegans is not very interesting. You know, it's sitting there or it's sitting there going, shaking a little.
Because it's a worm, yeah.
Yeah, but I found it really fascinating that the C. elegans not only can have seizures, but different kinds of seizures. I mean, we think of those organisms as being so primitive, but they're really very complex.
Yeah, well, actually, in the field I work in, C. elegans is used to study apoptosis, which is programmed cell death. Right. And I've seen videos, too, of it the whole organism undergoing apoptosis and kind of its cells eating themselves. And they look fantastic, those videos. But, yeah, you're right. I mean, apoptosis is another example of a very complex process that cells intrinsically have to sort of eat themselves, I suppose, undergo cell suicide. And it exists in C. elegans. Yeah. I
mean, the fact that we have all these pieces in common with lower organisms is one reason why we can figure out so many things about how neurons work using things like C. elegans or aplysia, and now fruit flies are becoming a real big experimental animal in neuroscience. That's good because we can learn so much without having to, use animals that have the kind of consciousness that would make us feel ethically challenged about using them.
Yeah, well, that's, another example of the model we're about to start using for ALS is zebrafish. We're actually going to be injecting neurotoxin. Well, in fact, we're going to be putting it into the water where the zebrafish live, and then they will make it into proteins, and that will impact on whether they get ALS or not. So I haven't worked with this model yet, but it's something it's established, and it's fascinating that you can go back to zebrafish and still look at ALS from that perspective.
Several years ago, I interviewed Dr. Eve Marder, who I think will someday get a Nobel Prize, and she has been at Brandeis for 30 years, and she's been studying the somatogastric ganglion in the lobster all this time. I mean, this one little batch of neurons, and that sounds like it would be she's actually been doing, the reason I think she'll get a Nobel Prize someday is because she's one of the pioneers in figuring out the circuit kind of stuff. And the thing she's figured out is that things that they've always assumed had to be the same can be very, very variable. One of the new ideas that's emerging is that one of the things that makes biology different from engineered things. With engineering, we always make things redundant. We need to have a backup one. Yeah. Usually it's exactly the same as the one that might break. Biology doesn't work that way. Its backups are usually entirely different. And what she's discovered is that some of the parameters of things like the ion channels can be vastly different and still end up with the same result. And this has some very big implications for how we do science, because the way we sample, we'll do an experiment many times and then average the results, sort of working from the assumption that all these organisms are going to be more or less the same in that thing we're trying to measure.
Yeah.
But it turns out that might not be true.
Wow.
I'm not sure where that's going to go, but that's just an example of one of the exciting things that's going on at the level of invertebrates. Invertebrates are turning out to be much more interesting than I think anyone ever. Just because they can't talk to us or look at us with things that we recognize as faces doesn't mean they're not interesting.
So one of the other interesting things I find about neuroscience is that, and you talk about this, is that the dogma was that you couldn't make new neurons for a long time. And we now know that that's not the case. Only certain parts of the brain, though, are capable of making neurons, aren't they? It's not the whole brain.
Right. I don't remember all the places. The main one that people know about is the hippocampus, because we know that's associated with memory. And there's been research in things like people that are depressed and people that get antidepressants. It looks like maybe that helps them to be able to make new neurons again. However, I think brain plasticity is a really, really fascinating field, but most of the stuff that's, to me, most interesting is things that happen that don't involve making new neurons, but involve either uncovering connections we didn't know we had or making new connections. I mean, it's amazing. You can take people that have normal vision and blindfold them for a week, and they can already... And you can already see changes in their brain.
Oh, right, really?
They start using parts that in sensory circuits that they weren't using because basically vision normally dominates.
So that whole concept that, I know it's a myth, but the one that we only use 10% of our brain. I mean, Ginger's just face palmed, by the way. But it's such a common misconception, isn't it? I don't know where it started from, but...
Yeah, I should know the answer to that, but I don't.
But you also used a really good example of how, with respect to brain plasticity, how memories are so pliable. And you used the example of the Challenger disaster. Can you tell our listeners about that?
Oh, yeah. Now, that one wasn't originally from me. I got it from Robert Burton, who wrote a very wonderful book called On Being Certain. Being sure you're right even when you're not. One of my favorite guests. Basically what happened was, and this was a study done by psychologists, when the Challenger disaster happened, they had a bunch of people write down their experiences, what they were feeling, what they were doing when it happened, and that sort of thing. Then a couple years later, they went back and interviewed the same people and asked them, what were you doing, what were you feeling? And there was only about a 25% agreement. Most people's memories had changed, sometimes in a significant way. And most remarkably, if confronted with their own handwriting of what they had said happened, a surprising number said, well, I wrote that, but what I remember now is what really happened. I mean, because your sense of the sureness of your memories is so strong that even if you look at your own handwriting, do you have any brothers and sisters?
Yeah, I do.
Have you ever talked about when you were kids and noticed that it's like you had different childhoods?
Yeah, I have. But it's really funny because now that I'm aware of this stuff, I always paraphrase those things with, I know it probably didn't happen like this, but this is what I remember now. Because I know it's really fascinating to think that I remember things now that probably never happened. And I'm aware of that as...
Yeah, I'm really looking forward to meeting Elizabeth Loftus. She's going to be here.
Yeah.
And she is one of the pioneers. She is the one that basically showed how easily it is to instill false memories, which is what hopefully put an end to that whole false memory, movement that was just really, really bad.
And it was really damaging too.
Oh, very damaging.
By implanting memories in children's brains of people that would then think they were molested as kids, and people were being prosecuted and going to jail for that sort of stuff. Yeah.
She did, I think the experiment that she did was, what she did was she had some people and she asked them if they had ever been lost in a shopping center when they were a kid. And then, I don't remember exactly how she did it, but she got them to remember that they had when they really hadn't. So it was a very benign way of demonstrating the principle, but in a way that wasn't going to do her subjects any harm. She wasn't implanting memories that were going to then, cause them to be traumatized or anything. Yeah.
Yeah, so you also talk about how emotion is intrinsically linked to memory. And so when that, what are the implications then for sort of skeptics and rationalists in that sense? Because we think as skeptics that we make decisions based purely on evidence and rationalism, but we can't uncouple that emotional aspect from our brains, can we?
No, we can't, because it's all in areas of the brain that we mostly don't have conscious access to. And yeah, I think that's probably the most important take-home message for skeptics is thinking rationally isn't ideal. Actually, though, it's been proven that if you don't have that emotional connection, you can't make decisions. You can't even decide whether to eat breakfast. So you really need that.
Yeah, you need that connection to make decisions, don't you? I don't think many people realise that.
Yeah, but I mean...
And then that's been shown in studies where people have had damage to that part of their brain, and they're unable to even make decisions about what pen should I pick up to write this down. It's such a fascinating area.
Yeah, we really need that emotional component, but we don't have very good access to it. I think it should teach us to be, well, one, more tolerant, and two, realize when you're talking to someone who is not a skeptic that just throwing more facts at them is not going to have any effect. It's just, instead, you might want to share something with them, but a lot of times it's just waiting till they're in the right place. So I think if you have a friend who, is, say, really into pseudoscience or some magical thinking thing, it's much better to be as tolerant as you can manage and set a good example of being, the kind of person who doesn't go around treating other people like idiots just because they disagree. Then if that person comes around at some point in their life, they're going to come to you for those facts when they're ready. But if you try to throw them at them or shove them down their throat, it's just not going to work.
It's not going to work, yeah. Well, thanks a lot for taking the time to talk to us today, Ginger. So where can our listeners find out more about the wonderful work you're doing?
The best place to find everything is either go to VirginiaCampbellMD.com, and you can get to both my podcasts from there, or if you're in iTunes, you can just search under Ginger Campbell, and you can find my podcasts and my podcast apps.
And on Twitter, you are Dr. Artemis?
No, DOCARTEMIS. Doc Artemis, as in Doc Artemis, the Greek goddess.
Right.
She was the athletic one.
Thanks very much, Ginger.
Thank you. Cool. That was fun. Hi, I'm Dr. Ginger Campbell. I started the Brain Science Podcast in December 2006 with the tagline, "The show for everyone who has a brain." Because you don't need a PhD to enjoy my podcast. All you need is curiosity about how our brains make us who we are. The Brain Science Podcast is not a self-help show, but understanding how the brain works will give you useful insights into your own behavior and the behavior of others. On the show, I talk about the latest books about the brain, and I interview leading scientists. Of course, I would love to be discovered by NPR. But until then, you can find the Brain Science Podcast in iTunes and at brainsciencepodcast.com.
And now we come to the second toss. Remember, the first number was 17. Oh, I better write that down. Okay, first one was 17. Let's toss one. Here we go. Toss number 2, folks. The 20-sided dice. Here we go. Are you thinking? Yes, I hope so. Use those neurons. Okay. Toss number 2 coming up right now. The number is 5.
I'm here at the Australian Museum here in Sydney, and it's Science Week. Well, it's the Science Week for the schools, I guess you'd say. I'm at their newly opened exhibition area here at the museum, and I'm surrounded by all sorts of little booths, all with science. We've got the University of New South Wales showing physics. We've got the Science and Education and Schools Tours organisation. A stand here about geography. What else do we have here? Featherdale Wildlife Park have a stand here. The University of Sydney's represented. The Young Scientists of Australia are here with their stand. Jenolan Caves, which are a very famous natural cave formation west of Sydney, are here. And all sorts of other things. We have some optical illusions. What's this one? University of Newcastle. Science and Maths, it says. And there's some classic optical illusions on the wall. Now, I'm here today to have a chat to the newest member of the Australian Skeptics here in New South Wales Committee, Karen Player. Karen actually works at the Australian Museum, and she's busy at the moment at the one of the stands here, giving information to children. And the children you can hear, no doubt, are all primary school or elementary school kids. There's about 200 kids in here all running around, going from stand to stand, exploring and trying out the various science. Some have got their face painted. It's a really great thing that the Australian Museum do here every year. And I'll see if I can just chase down Karen in a moment, and we'll have a little chat to her about what she does here and how important it is that science is presented to kids in this way. So we've snuck away from that noise and chaos downstairs with all the kids running around, but it was really good to see it. I'm with Karen Player. Hi, Karen.
Hi, how are you going? I'm
well. Now, congratulations, first of all, for being invited onto the committee of the Australian Skeptics New South Wales.
Thank you. I think it's going to be really exciting. Hopefully it's not going to be too scary.
Scary? Oh, you've got no idea. Your first assignment is to go to the most haunted place in Australia and be bored to death like the rest of us when we go. Now, as a welcome present, I've decided to give you, just to kick you off, so to speak, so you can really get stuck into skepticism. I've given you a DVD of our water divining adventures here in Australia called the Great Water Divining DVD. I've given you James Randi's The Secrets of the Psychics.
I'm looking forward to that.
That's an interesting one. He travels to Russia and investigates things, and it's all about his looking at Uri Geller and all sorts of things. And I've also given you a copy of the Full Facts book of cold reading, so you can start to get your education going.
Practice on my friends.
Practice on your friends. I mean, we could dress you up as a gypsy when you get...
You can do all sorts of things.
There's so many things to know when you're into skepticism. But be that as it may, I have found it really interesting that your work here at the museum, and I'd like to chat to you a little bit about that, and especially what was happening downstairs.
Yep, absolutely.
So, as I was mentioning before to my listeners, that was a new exhibition space.
Yeah, so the Australian Museum's been looking at how we can fit bigger exhibitions into the museum, so we've been doing a lot of refurbishment over the last 5 years, and it's a brand new space, and it's really exciting that the first cab off the rank was the Science and the City Expo, so we were very excited to be able to use that space for all of the science activities for the kids.
Now, the Science Week, is it already started or is it next week? I can't
We
sure.
start a little bit early.
I thought so,
So we're a little bit ahead of National Science Week. So we have the 2 weeks of Science in the City, and then I think the week after is the National Science Week.
Well, every week's Science Week,
well,
isn't
that's
it?
right. Well, here at the museum, absolutely.
Now, it's a good attitude to have. What is your regular position here at the museum?
I work in a program called Museum in a Box, which has been going for about 47 years now. And it's an outreach program getting museum quality specimens and educational resources out to regional New South Wales. So at the moment we have about 28 different topics ranging from, Indigenous cultural activities, boxes for childcare centres, boxes on different animals and different habitats, all the way up to boxes for, Year 12 science. We have a lot that goes out. I think this year so far we've had about 520 boxes heading out around the state.
That's fantastic. Of course, outreach is something I'm deeply interested in, and I do, of course, with the Mr. Investigators with Dr. Rachie. And we'll be doing that show on the 20th here at the Powerhouse Museum, in fact, as part of Science Week. And as we were walking into this little room so I could have a chat with you, I noticed on the wall some photographs which warmed my heart of the old museum train, which used to travel this state from the Australian Museum. It was brightly painted on the outside with the museum, and I remember as a boy visiting the museum train when it stopped in my little town of Mullumbimby.
Yeah.
And that would have been, I'm guessing, 1978, 1979, 1980, around that time. Where is the old museum train?
I don't know where it physically is at all. Funnily enough, a lot of the specimens and objects inside it were taken out and were then absorbed into our hands-on collections and our search and discover area. So, I've seen some photos recently when we were moving offices that had some of the same specimens that we're still using today that were on the train. But we get people that do come into the museum that grew up in regional New South Wales and remember the train really fondly. So it was one of those great programs, but I think it just became unsustainable.
Yeah, I guess that's not surprising. There would have been some cost involved in carting that thing around. But it was so exciting. I remember just the excitement, and I would go there. I was one of the kids who would go there every afternoon after school and just hang around and pester the people who work there. They say, "Oh, it's you again," that sort of thing.
Which is exactly what it's there for, to enable those kids that really have that fascination and really want to explore and learn more, to give those kids an opportunity to get access to those kinds of objects and specimens.
Yeah, I remember the snakes quite well. Actually, there was several different snakes, and you could actually handle them. They would let you pet them. So I suppose they weren't the venomous ones.
Well, things have changed a little bit with Museum in a Box. We certainly don't send out any live things anymore. That would be a bit of a surprise to the teachers. But, over the years we've had a lot of different outreach programs. We did have the train. We've had, I think there was a bus that used to go around as well. We also, up until about 5 years ago, had a program called Museum on the Road that was both an Indigenous, and then another one was a dinosaur one that would go out. Now, those kinds of things, we're always looking at reinventing those kinds of activities, but Museum in a Box is one of those ones that's outlived them all. It's been around longer than the train, and it's still going.
So the idea is basically teachers and get a box.
Yeah,
is that the crux of it? Yeah,
so it goes to teachers. Often the school library will take it, and some of the central schools and regional schools will have everything. Every single student will have access and will go through. They get them for 3 weeks. It gets sent out. We organise all of the freight and delivery, and they send it back.
And do you find that you do much travelling in this job, or are you really based here at the museum?
I do try to get out and about, at least once.
I would if I was in your shoes.
At least once a year I try to do a big regional trip and try to pick an area that we don't have a lot of access to. So it'll often be, it'll rotate around. There's some areas that are really strong users of the program and other areas that don't at all. So we try to target those areas and go visiting. Unfortunately, I go at the wrong time of year.
Wrong time of year?
Well, I went west last year in the middle of winter, and it was it got very cold, and we were camping, so it was a bit of a challenge, but an exciting trip. And as part of Science in the City and those kinds of programs, we run Science in the Suburbs and Science in the Bush.
Yeah.
And so I'm often part of those. So they go out to regional centres as well. So I try to go to as many of those as I can.
I think I was involved in Science in the Suburb about 4 or 5 years back.
Out at Sydney Olympic Park.
Yes.
Yeah.
Indeed, I was doing the Mr. Investigator show. That's right. Yeah.
So we still do that every year. So I was out there for this year's events, and I'll be going out to Orange and Narrabri in September for the Science in the Bush there as well. So they've also done Wagga and Albury. I think they did Dubbo last year. So they do all of those regional big science events. So it's like mini Science in the Cities, but we go to them. So that's a really exciting program, and I try to go to as many of those as I can, so I can get out bush as well.
It must be very gratifying.
It is. When we had a really exciting one that we just started doing video conferencing for a lot of regional schools as well.
Right, yeah.
So it was our first year that we'd done video conferencing, and we had through the Country Areas program had all of these regional schools. I think we had 25 schools and about 1,000 students in one one video conference, which was a bit daunting. But 2 weeks later, we were down at Albury, and I had a student come up to me and said, "I saw you on TV."
Oh, really?
And so this student lives 4 hours out of town, away from Albury, in a really remote regional area. And within the space of 2 weeks, they'd had 2, face-to-face contacts with Australian Museum staff. So that was one of those really exciting moments to think that the students are really, they were so excited to see us there live, that we made the effort to go down there to see them, but also that, because it was through video conferencing, we'd be kind of, you came to see us. So when we do video conferencing and things like that, the kids will say, "I went to the Australian Museum," even if they've never left their school. So it's really, really exciting that we can use our physical presence in going out to events as well as our video conferencing and resources like Museum in a Box. So, we really do try to get out there to sort of some of the remote places.
And New South Wales has many remote places when you think about it.
Yeah.
Off the beaten track, I mean, if we're thinking about way up in the north west of the state. I don't know. Do you have a program where you try to cover every part of the state over a number of years?
We are looking at it. This year I was going to go to Bourke. But unfortunately I'm not going to be able to go physically, and I'll be actually doing that via video conferencing now. And they are looking at whether or not it's feasible to do a Science in the Bush at Bourke.
Yeah.
They have talked about doing one at Broken Hill. The further away we go, the more difficult it is to get funding to be able to go out and run the event. So, we do try to really look at where different events are and how we can get really good coverage. So it's just a matter of trying to rotate around a little bit. A lot of the Science in the Bush events run at the university campuses.
Oh, yes.
So, they have partnerships with a lot of the universities to be able to go out and use their venues.
Sounds like a very good idea. For our, especially for our United States listeners, when we're saying this is involved with this state we're in, New South Wales, the states in Australia, by and large, are really big.
Yes.
I mean, you could fit many of the United States into just our state of New South Wales, and if to save me explaining it to you, just run to Google Maps and have a look at the size of New South Wales. So it's a daunting task. Do other states have the similar program? I would imagine they do.
Yeah, certainly the Queensland Museum has a really strong loan program as well. We do try not to cross too many borders, we let Queensland do what they do best. They run their program slightly differently to the way we do. Everything comes from us, the hub here, and goes out, whereas because Queensland is even bigger a state than New South Wales, they have some regional hubs that they send the boxes to, and then that location is in charge of sort of sending their box type program out from those regional hubs. So it's a slightly different way that they structure it because they are such a big state.
Oh yeah, and Western Australia too is even bigger.
Yes, that's right.
You could fit New South Wales and Queensland into Western Australia. I think,
with a bit of space to spare.
Yes, that's
probably.
Right. It's ridiculous. Now, if people especially in this state of New South Wales, are very interested, I'm sure, in what you're doing, and may be very interested to find out more. Mm-hmm. How can they find out more?
Well, certainly the Australian Museum website is great. AustralianMuseum.net.au.
Mm-hmm.
From there's a whole section on education services where you can see a lot of what we're doing. It's got Museum in a Box, it's got on-site visits, it's got Science in the Suburbs, Science in the Bush, Science in the City, it's got our things on video conferencing, and it's got a lot of online resources for teachers as well. So that's a really good way. And you can email me or contact me through the website.
And Karen Player and your details are on the website.
That's right, yeah. You can search me on the website too, and you can come up and it has my phone number, and you can send a direct contact email just from that. Clicking
How easy?
It is
how
very easy.
Is that?
We do love technology.
The days when I used to run to the train in the late 70s, because that was one of the biggest events that happened in my little town, probably all year. And no, it was so good, and the fact that I still remember it fondly, how umpteen years later, is a good indication. And I hope probably a lot of listeners who grew up in country New South Wales will probably be right now thinking, I remember the museum train.
Yeah, we definitely have lots of people that have those memories. We actually have a couple of staff members here that came from regional New South Wales and remembered Museum in a Box and remember the train. And, I've had people say to me, I wanted to work at a museum because of Museum in a Box. So I can't take credit of what happened, before my time, but I've been working on the program for the last 4 years, and it's probably, been a bit of a highlight of my time here at the museum.
Fantastic. Well, Karen, welcome to the wonderful and wacky and bizarre world of skepticism as well.
Thank you.
And I'm so pleased that you're doing such great outreach work here at the Australian Museum.
Thank you.
This is Carrie Poppy.
I'm Ross Blotcher.
Oh, hey, Ross.
Hey, we're from a podcast called Oh No, Ross and Carrie. We find out what happens when you show up and ask questions.
We've hung out with the Kabbalists.
The Mormons.
We've gone and gotten ear candles.
Gone to the Sikhs.
We show up so you don't have to.
So find out where we're going next.
We'll even have special episodes where we have famous guests like Brian Dalton from Mr. Deity.
You heard that awesome theme music? He wrote that.
You should come visit us at onopodcast.com or
facebook.com/onrack.
What the hell's OnRack, Ross?
ONRAC. Oh no, Ross and Carrie. That's our show.
That's so smart. Come join us.
And now we come to dice toss number 3. All those people out there who predicted 17 for the first toss and 5 for the second. Oh boy. I bet you can't wait. Here it comes. Think of the number. Warming up the dice now. Here it comes. The third number is 15.
Well, with Science Week kicking off, I've come down here to Martin Place here in Sydney, the great pedestrian mall, where I've just missed, in fact, the the kickoff to Science Week. However, there are still some people here as the rain comes down, and I'm at this wonderful stand here, run by none other than Galit Segev, the wife of Rachie Segev from A Grain of Salt and the Australian Skeptics. And she's got a whole stand here dedicated to chocolate. Oh, yes. Oh, yes, friends, chocolate. In fact, there's cocoa beans here and powder and all sorts of... There's milk powder, cocoa butter, lots of different varieties of chocolates on display, and I might be able even to have a sample of that. Let's find out a little bit more about why there's so much chocolate here. So I've caught up with you. Hello, Galit.
Hello, Richard.
Hello, nice to see you again.
Lovely to see you, Richard.
Thank you. Sorry I turned up late, but the traffic today was terrible. What did I miss? I know we're surrounded by chocolate. Why are we surrounded by chocolate?
Because I love chocolate.
There's going to be a better reason than that.
No, because I love chocolate. And chocolate is very interesting in terms of the science behind it, because it is quite an interesting thing to work with, because cocoa butter is a very complex fat that can solidify in 6 different forms, and that will influence how your chocolate will look like. So if you have the right form of crystals in your chocolate or in your cocoa butter, you will end up with a product that have a snap and have a gloss. And if it's not, you will end up with really dull product.
And we're looking at some now on the table here. We've got that's
untempered chocolate. This is the same chocolate that is out of tempered, so you don't have the correct or the desirable crystals, and that's why it changed the appearance, and it has like a grey, powdery appearance.
It looks like it doesn't look very edible, does it?
No, but you can eat it. You won't be sick. It's the same.
Yeah, really.
And just out of tempered. So what's happened here? I melted my chocolate, and then the fat and the cocoa butter did not solidify in the desirable way that will give you the snap and the gloss that we are after.
Because you've got that next to the real stuff here, the real commercial stuff, which is, just break some of that off. It looks lovely and shiny and
very nice as well.
I get to eat the chocolate, folks. And we've got lots of jars of chocolate along. White chocolate, dark chocolate, milk chocolate.
Yes, and the different chocolates have different things inside them. So, for example, the dark chocolate is made from cocoa mass, which is the center of the cacao beans grinded. And on top of that, we have in the dark chocolate sugar. In the milk chocolate, we have the addition of milk powder or milk solid. So we're going to have the cocoa mass component. We're going to have the sugar, obviously. And we're going to have there the cocoa butter and cocoa powder. The white chocolate is different, and the reason that it's different is because we don't have the cocoa powder there. That's why the color is white. So in the white chocolate...
I quite like white chocolate. I think a lot of people do, yeah.
I don't like it. It's too sweet and too sickening for me. I like the dark one, the full-on bitter
This one. I'm picking up the jar now. This is the dark chocolate beans. Yep. Oh, they look good.
Yep.
But they all look good to me. I mean, I enjoy every form of chocolate, I think. Especially chocolate with a bit of chili in it.
And chili, nice. That's very nice. Chocolate and chili.
Just before, I was very lucky. I got the last little taste of a very interesting chocolate. There it is under the table. It's chocolate and blue cheese.
Exactly.
What an interesting taste.
It is interesting, and that was the whole point, not just to make something that you try everywhere. It's about stepping out of your comfort zone and trying different combinations. And the dark chocolate and blue cheese are a really nice combination together.
I must admit, I tasted it, and I could taste blue cheese, and I could taste chocolate, and it's a bit confusing, because I've never had the two together. Mm-hmm. It wasn't bad, it was just very unusual.
Unusual, yeah. And that's the whole point, to have something a bit unusual. And making this ice cream with liquid nitrogen actually contribute to a very, very cream, smooth texture.
But you went to visit Dr. Rachie, I understand.
I did, and actually made a few batches of ice cream with Rachel, a lovely Rachel that was so nice to host me and help me with liquid nitrogen. So it's a good opportunity to thank her for being so lovely and hospitable and help me with my ice cream.
It's good to know a scientist, isn't it?
It's always good to know a scientist. The more the merrier.
And I can see Rachie Segev himself over there. He's helping himself to some of the leftover chocolate. He's got his mouth full.
It's very dangerous.
So your little stall here in the middle of the city today, that was very popular, I think.
It was actually, because people love chocolate, and I think to understand chocolate makes you appreciate the product even more.
Yeah, and especially when you get to know a little bit about the science behind the chocolate, it tastes even better. Yep. Now, people can certainly, if they're interested, and I'm sure they will be, in what you do, they can visit your website, which is?
The website is www, of course, galit.com.au, and I'm going to do a few events during the Science Week in different places. So a few chocolate events, a little bit of molecular gastronomy in the Botanic Gardens, so a lot of interesting stuff for kids and for adults. So all good.
That's really good. I might come along to every event. Just to make sure the chocolate's up to quality, so that's www.galit.com.au. Galit, thank you for your time and thank you for your chocolate.
Thank you very much.
Thank you for listening to the Skeptic Zone this week. What an interesting show. On next week's show, even more from TAM Las Vegas. The more I think about it, the more I just can't believe that we got so much material from TAM Las Vegas. Well, thanks very much to Dr. Rachie, who was there slightly longer than I was. And thank you to those people who have been writing and asking about the think tank. Yes, we haven't had as many think tanks as normal lately, partly due to me being very busy with television commitments. And also it's just not always easy to get everybody together. But we're going to have a try for a good old-fashioned back-to-our-roots think tank, hopefully next week. But until... yes, I was forgetting the last toss. The last toss. So... toss number 1 was 17. Toss number 2 was 5. Toss number 3 was 15. Here we go. If anyone gets this last one, you've beaten odds of 160,000 to 1. The last toss of the 20-sided dice. Last toss is number 10. This is Richard Saunders signing off from Sydney, Australia.
You've been listening to the Skeptic Zone. Visit our website at www.skepticzone.tv for comments, contacts, and extra video reports.